इनवर्स सीकेंट फंक्शन पे आए हम, तो द प्रिंसिपल सीकेंट x है y इज इक्वल टू सीकेंट x, ये एप्लीकेबल है व्हेन x इज ग्रेटर देन और इक्वल टू 0 to x is greater than or equal to pi, but x should not be equal to pi over 2 because at this value it is undefined. So it is the principal secant function, and this is one to one and has an inverse, and the inverse secant function is defined by y is equal to secant inverse of x if and if only x is equal to secant of y, where y is equal to from 0 to pi, and but y is not equal to pi over 2 and x has absolute value greater than 1. It says that students should draw the graph of y is equal to arc secant by taking the reflection of y is equal to secant x in the line y is equal to x. This is left an exercise for them. So we will do this. Let's plot this. Since it's an exercise for us, so let's go and apply this. First of all, this is the secant x. You can see that every pi by 2 minus pi by 2, this is becomes undefined because here the cos is undefined. So in order to get the principal secant x, we plot. You can see that this black line and this red line is the principal secant x, and you can see this is the secant x, and minus pi by 2 is not included because here it is undefined. So here function is one to one. You can place any horizontal line and it will touch the axis only once, or here also. So the principal axis is secant is 0 to x, 0 to pi, but excluding pi by 2. So now we plot the x, and now we will reflect this these two lines along this green line by plotting the inverse of x. So you can see the inverse of x is like this. So you can see that the inverse secant has the domain of x greater than minus 1, or x greater than plus 1, and its range is 0 to pi. So 0 to pi, its range is 0 to pi, and where pi is not equal to y is not equal to pi over 2. Here you can better see that its domain is less than minus 1, this line, or greater than plus 1, this line, and you can see that its range is 0 to pi. So maximally, minimum it touches 0 at this, and maximally at x-axis it touches the pi value. So its range is 0 to pi, and domain is less than minus 1 to all numbers, or greater than 1 to all numbers. So inverse cosecant function is the next. Y is equal to cosecant of x. So this is the principal function where y is equal to it should be x is equal to minus pi over 2 to pi over 2, and x is not equal to 0 is called the principal cosecant function. So let's see cosecant function. If we apply the cosecant function, we can see that since at every pi it becomes undefined, so where the sine theta is not defined, cosecant is also not defined. So this is a graph of the cosecant function. So if we want to plot the principal axis of the cosecant where one-to-one function is there, then we can plot here. So this is the principal cosecant function where the horizontal line test can pass. If you cross the horizontal line, it will touch this axis only, this graph only once. The one portion is here and the second portion is here. So if we plot the x line, you can see that x line is passing through this, and if we plot the inverse cosecant, you can see these blue lines are the graph of the inverse cosecant functions. And the table in the book tells that the principal function has the domain of minus pi by 2 to pi by 2 including, where x is not equal to 0, and range is y is equal to less than minus 1 or y is equal to greater than 1. While the cosecant inverse function tells us that x is less than minus 1 or x is equal to greater than 1. You can see this range and domain and range is minus pi by 2 to pi by 2 including, where y is equal to 0. Here you can more easily see that the domain is x values less than minus 1, so these all values, or x is greater than 1, so these all values are included in the domain of this, and the range includes minus pi by 2 and pi by 2 including for inverse of cosecant x.